What's up? It's your boy Yasar again, and today we are going to discuss the code that is used in the Arduino joystick. Now I know that I discussed the code in the video of making the Arduino control itself, but then as usual I have made a couple of pretty silly mistakes in that as well. So this will be a lot more in-depth than the original explanation, and it's in a separate video, so then you could just watch this and then make your control as you want. So first of all, how do you include this joystick.h library? You could use joystick.h only on Atmega 32U4 processors, which is the Arduino Pro Micro and the Arduino Leonardo. So to use that, you go to Tools and then Sketch, include library, and then add a zip library, and then you download your zip library from the internet, and then you select it from here. And after you add it from here, you scroll down and you'll see it somewhere down here. So because I already added it a bunch of days ago, it is as well, and that's right here, joystick. So you click on that and that will import joystick.h, and this is to actually make the joystick. So joystick underscore joystick, that makes the joystick. And then we set up 4 variables which are determined by our analog inputs: x-axis underscore equals 0, y-axis rx, which is x-axis rotation, ry, y-axis rotation, all of them you set it to 0. Now what's this? Constant boolean initialize auto send state. What this does is that it makes the entire Arduino board self-identify itself as a game controller when you plug it in. So that's what constant boolean initialize auto send state is for, and then you set it to true. Then void setup is already created in your raw sketch, and then you include this set. So this is for your digital inputs: pin mode 2, input pull up. So what this does is 2 is the pin number, 0 and 1 are used for the TX and RX pins. So it starts from 2, 3, 4 all the way to 15. So there are 3 things you can put here: output, input, or input pull up. So when I put input, it configures it as an input but without any pull up or pull down resistors. So that means if I don't actually use a physical resistor, this is going to become a floating value which could vary between logic high or logic low. So what I did was to make things simple. By the way, Arduino has only pull up internal pull up resistors. It has no pull down resistors. So therefore I put input pull up, and then I made the switches so that when the switch is pressed, that certain pin is sent to ground, which is logic low. And then later in the code, I'll get to that later. Later in the code, I set it to pressing a simulated button when the actual signal is logic low. So anyways, we begin the joystick.begin, and then close the setup loop. Now what's void loop, open brackets, close brackets? So this is meant to run infinitely until the controller or the Arduino board is unplugged, which is essential. We don't want a time limit for this. So x-axis equals analog read A0. What does that mean? We assign this variable called x-axis to analog read A0. That means we take the analog input A0 and we read that value. Now it is assigned to as an integer of x-axis, which is initially 0, and now we have whatever the value which is being input into a note, and then x-axis we map the range of the x-axis we map the range of x-axis from 0 to 1023. So how do we decide which value to include here? If we take the analog to digital converters, these are 10-bit converters, therefore we put 10, we put 2 to the power of 10, which gives us 1024. These converters can take up 1024 different values, which can be mapped from 0 to 1023. Now when we are exporting the serial data, we export it between 0 to 256, which is a different bit depth than the analog to digital conversion, which happens to be an 8-bit export. So therefore it can take values from 0 to 255. Then this is what actually sets the simulated x-axis of the joystick being sent out by the serial data. Joystick.set x-axis open brackets x-axis underscore close brackets. This variable is the same as this, so which means whatever your analog input is going to be mapped onto the virtual joystick. The same thing goes for this, which is the y-axis, then the rx-axis and the ry-axis and the rx-axis. Now the issue here is that in my initial code I put A3 here and A4 here. Now A4 doesn't even exist on this board, and what I changed was simply changed A3 to A2 and then A4 to A3. And also I made these two the x and y axis, which is actually one joystick which is on the right side. So the two wires on the right side joystick goes to A0 and A1, and then our y-axis is the left joystick, which is only limited to the y-axis, and then rx-axis is for that middle circular controller, circular encoder. So that's about it for this entire thing. Now also the y-axis is inverted, 255 first and then 0 next. If you want to invert any of these axes, you can simply put 0 in front and then 255 next, or else 255 first or 0 next. By the way, if you are going these, so there are these labels, right? These labels are actually very limited in the joystick.h library. You can use only a few predefined ones. For example, you can use, if you download the joystick.h library, you can see they have given a few examples, and in those examples they have given certain variables. You can only use those variables in the joystick.h library, because the joystick.h library cannot configure the Arduino to put out custom labels. It's only a very predefined set of them. So read the Arduino library and then you'll figure it out. So moving on to the digital pins, it's similar to the analog read, but then we put it inside an if condition, because we want two things to happen per cycle. So if digital read 2 is low, that means you're sending that pin, which is actually a high, into the ground terminal, which is logic low. Then that simulates the pressed button 0, button not. So button not is a simulated button, which is just a label. Otherwise, it simulates button not being released. So if it's sent to low, which means the actual button is pressed, the joystick button 0 is simulated to be pressed. Otherwise, if this is logic high, the joystick button 0 is simulated to be released. Same here with pin 3. If it's low, button 1 is simulated to be pressed. Otherwise, it's released. Then we move on to a tiny delay, which is pretty much negligible. You can put any small value for this thing, and then end of the cycle, go back to the loop, and it goes on and on and on until you unplug your joystick from the computer. So yeah, that's about it. In the future, I'll be updating this project with a bunch of additional stuff like more buttons. I have a plan to add about, quite a bit of buttons to this thing. Something like to enable functions of a D-pad, and it's pretty much getting somewhere close to an Xbox 360 controller. Of course, very far from it, but then from whatever I can salvage from used stuff. So yeah, see you guys till next time. Ciao.